All right, guys, let's do this last problem. This is a lot shorter than the vitamin problem. So you're making some planes, okay? So let's say x equals number of camels per day. Okay, y equals number of hippos per day. Okay, and then you gotta be careful because they switch the order. Okay, so no more than 7 hippos can be made. So that's just down here. Let's write that. So hippos are y. So we got y is less than or equal to 7. Okay, we know y has to be positive. Okay, or let's even write it compound at first. So bigger than or equal 0. We know x is bigger than or equal 0. And the number of camels per day is less than or equal to 11 that they can make. Then it says no more than 12 total can be made. So x plus y is less than or equal to 12. We could say it's bigger than 0, but that's redundant because we already said x and y are bigger than 0. So then their sum is. Then we've got, you can't manufacture. So the number of hippos, that's y, can be no more than, that's less than or equal to, twice the number of camels, that's 2x. Okay, in labor, you must use a certain amount of hours. You got to employ those workers, okay? So we've got, it takes 100 hours to make each camel, that's an x, plus 200 man hours to make each hippo. And that has to be, you must use more than, so that's greater than not equal to 1,000. All right, those are all of our equations. Let's just rearrange those now. So if I rearrange this, I get this is 200y is greater than negative 100x plus 1,000. Oh, my writing is so bad at that edge of the keyboard. We divide by 200. We get y is greater than negative 1/2 x plus 5. All right, and then this top one too, we can rearrange and just get that top one. So y is less than or equal to negative x plus 12, okay? So if we rewrite all of our inequalities separately, we got y is bigger than or equal to 0, y is less than or equal to 7, x is bigger than or equal to 0, x is less than or equal to 11, y is less than or equal to 2x, y is less than or equal to negative x plus 12, and y is greater than negative 1/2 x plus 5. Okay, so first things first, let's graph that, and then we'll go read all the instructions. Okay, so I'm just going to go by ones here. So x is bigger than 0. We'll just start in the first quadrant. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I think we just need to go to 15 on each. So we'll go, oh my gosh, are you kidding me? I started at 1. What a goof. Guys, you know I can't count. It's my weakness. Okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're almost there. 11, 12, 13, 14, 15. Okay, man, my writing is so bad. Okay, and we'll do the same thing over here. Start at 0, okay? Oh, I went 13, 15. I told you I can't count, you guys. Okay, y is less than 7, okay? So our first one is this line, okay? Y is less than 7. And then our next one is x is less than 11, okay? Assuming I didn't mess up counting again. These are in the right place, okay? Oh, it's snapping. Okay, there we go. And we got y is less than or equal to 2x. So 2x, we're going to go from this point, we'll go up 2 over 1, up 2 over 1, up 2 over 1, up 2, go just over. There we go. And so we are less than this line. Okay, and then it's got less than or equal to 12 y-intercept and negative 1. So 12 at a negative 1 slope just goes to 12 over here. Okay? So far, we got our region is we are underneath those two diagonals, but we are within this box. So it's that little like triangular kind of region there. But we got one more to do. We got y is greater than negative 1/2 x plus 5. So 5, 1/2 down, 1/2 down, 1/2 down, 1/2 down. We should end at 10. Okay, let's just put another dash in there. This is a dashed line. Okay, there we go. So this is our viable region. We got 7 different rules. Okay, 4 of them just make a little rectangle here, and then the other 3 are the diagonals. So let's shade our viable region in, let's do pink. Okay, that's a pen, not a highlighter. Okay, this is our viable region here. All right, so now that we got our viable region, we need to figure out our max and our min. So we could just get the corners and plug them in, but this word problem's got some other things. So first, we did A. Got it. Okay? If they make a profit of 300 per camel, 200 per hippo, show the region where the profit is bigger than 3,000. Okay, let's figure that out. So 300 per camel plus 200 per hippo. Let's just make sure X is camels. It is. We don't want to get mixed up. That's the profit. And we want the profit to be at least, that means including, so 3,000. All right, so let's divide all that by 100 just to make it easier. Okay, so we got 3x plus 2y is greater than or equal to 30. So 2y greater than or equal to negative 3x plus 30. We got y is greater than or equal to negative 3/2 x plus 15. Let's go ahead and graph that. I'll graph it in brown. So starting at 15, we're going to go down 3 over 2. So 15 down 3 over 2, down 3 over 2, down 3 over 2, down 3 over 2, down 3 over 2. There we go. And so here's our line where the profit is exactly equal to 3,000. Okay? Now we know that y is greater than that, means the profit that is bigger than that is on this side. Whoops, I'm going to do it in brown so we could see. Okay, so this side is where the profit is bigger than 3,000. I mean, we also can logic. If we plug in 0, 0, the profit is 0 over there. So yeah, we know this is the side where the profit is bigger. Okay, so what does that tell you? That tells you in our little region, okay, there's only, let's go back to pen. There's only this vertice, which misses this vertex, which is in it, and this vertex, which is in it. So it's one of those vertices. So it's either 11, 0 or 11, 1. And obviously, we're going to make more profit if we make one hippo than if we just do 11 camels. So without even plugging it in, that's not our max. We know the other one is, but we can plug them both in. So let's see what we get for the profit. 11 times 300 plus 1 times 200. That's 3,300 plus 200. So our best profit is making $3,500 per day by making 11 camels and 1 hippo. Woo! That was a fun problem, you guys.